trig ratios are inverse functions. Does that make sense to you? Which means they're not one-to-one. Meaning the inverse is a function. So that should make sense to you, except that you're saying, well, wait a second, I thought there's an inverse trig function on my calculator, so what are you saying? So what they have to actually do is, and if you think about this, like if you look ahead here, the sine function, you know, it goes on forever this way, right? And so if you were to do it as a function, that's the vertical line test. Of course, the sine is a function, but the inverse, which would be the horizontal line test, you see it would fail, right? So that means you can't actually undo a sine function unless we restrict the domain. So, however, when the inverse, when the function, what do I want there? Hold on. When the domain, that's what I just said, when the domain is of a trig function is restricted to a certain interval, the restricted trig function does have a domain. So does everybody see if I restrict the domain to a number here, which you could probably guess what it is, to a number here, do you see no matter where I put my pencil, it would pass the horizontal line test now? Okay, so did you ever wonder on your calculator when you find the inverse of, say, I don't know, say -1/2, why does, of sine, why does it give you -30 degrees or -π/6 and not positive? Why is it negative? Huh? Yes, okay, so exactly, the cast rule. The cast rule. So -1/2, but then why does it say it as -π/6 versus this way as 11π/6? Or over here, it could give you this answer, which would be 7π/6, right? The calculator only gives it to you as -π/6, or if you're in degrees, -30 degrees. And so this is the reason why. It's because in order for it to actually perform the operation, it has to restrict its domain between -π/2 and π/2, which is basically this going this way and this going this way. So when the answer is in the fourth quadrant, it's named as a negative angle. Okay, because of the fact that this is an inverse function. So the sine function is not one-to-one, but the sine with the domain -π/2 to π/2 has an inverse function denoted inverse sine. I could say, I'm going to put y equals that just to make it. Thus the definition of y equals inverse sine of x for x is an element of -1 to 1 if and only if sine y equals x for y is an element of -π/2 to π/2. So what this means is you know how the inverse, you switch the x and the y around? So you see I'm actually switching x and y around. And so remember, this -π/2, π/2, these are your x's. So when I'm talking about the inverse, that'll actually end up being your y's, right? Okay, so let's see if you truly understand what that means. What is the inverse of inverse sine of 1/2? There's only going to be one answer, because remember, your calculator only gives you one answer. Is it π/6? Correct. It's the finger rule, but it's in the, remember, all our answers have to be between here and here. Yes, right. Okay, how about this one? Because that's the only way you can actually find the inverse function, is if it's between these two. Okay? No, I'm just restricted the domain so that the inverse sign can exist. Okay? So inverse sine of negative 1 over root 2. That's the same thing as root 2 over 2, just so you know. Which one? Is it pi over 4 or negative pi over 4? It would be negative pi over 4. And why would it be negative pi over 4? Because negative root 2 over 2 only exists in quadrant 3 or quadrant 4. So when I list any answer in quadrant 4, it has to be. So now you might be thinking, well, wait a second. Didn't we actually do inverse sines last year? Okay, so this is how last year it was stated. It was stated as sine x equals 1/2. And you actually impose the inverse sine to both sides, right? Yes? That's how you undid this, and you got x is, what's the inverse sine of that? And then you started listing your solutions, depending if they gave you a domain from 0 to 2 pi or all reals or whatever, right? So it's kind of like this. The square root of x equals 25, or x squared equals, sorry, I want to say it this way. The square root of x equals 5, or this. So do you see, when I perform the operation of square rooting, I get 2 answers. But when I actually am trying to figure out this one, I actually only have 1 answer, right? Yeah. I should actually write it like this to truly make the difference like that, right? You only get positive 5. Here you get negative 5 and positive 5. So this is the difference between, I guess the reason I'm showing this is the difference between when you're solving for an equation and performing that operation versus when it's stated like this. When it's stated like this, you can only have 1 answer. It's not all reals. It's not all the answers between 0 and 2 pi. It can only be within this domain. Okay? Yeah. Inverse sine of root 3 over 2. What would that be? Pi over 3. Very good. Okay, inverse sine of negative 1/2. Inverse sine of negative 1/2. Negative pi over 6. Very good. Inverse sine of 1. Pi over 2. Very good. Inverse sine of 0. 0. So, and normally you could say, well, there's also 2 pi, but no. It has to be between these two, and you can't, do you see, in order to get to 2 pi, you'd have to go all the way around to get to 2 pi, so that doesn't exist. You're only going from here to here, or from here to here. That's the only way your answers are. Yes. The cosine function, I have to restrict the domain a little differently, because if I did negative pi over 2 to pi over 2, it wouldn't pass. Okay, again, I'll repeat. Cosine, I can't restrict it from negative pi over 2 to pi over 2 because it still would fail the horizontal line test. So I have to restrict it from 0 to pi. And of course, this is y equals inverse cos of x. So let's try this now. What's the inverse cos of positive 1/2? Pi over 3. What's the inverse cos of negative 1 over root 2? It's 3 pi over 4. Very good. Do you understand why? It's in the second quadrant. It's negative. Remember, cosine is now from 0 to pi, right? So these things you have to memorize. You can put it on your recipe cards or whatever that I say, that this long list of things you have to memorize. The domains of that. So inverse cos of root 3 over 2. Inverse cos of root 3 over 2. Pi over 6. Very good. Inverse cos of negative 1/2. Okay, so cos is negative over here. So what would it be? 2 pi over 3. And so negative root... Yes, it would be in the second quadrant again. It would be, what did you say? 5 pi over 6. Yeah, 5 pi over 6. Again, you have to think of where is cos negative, and it's only negative over here. So it has to be whatever that family is in the second quadrant. Negative a half, it's at the pi over 3 family. So the only pi over 3 family in the second quadrant is 2 pi over 3, right? Okay, if I find... Okay, so we need to find sine of 5 pi over 6. And what's that? It's positive 1/2. And then inverse cos of positive 1/2 would be pi over 3. Very good. Okay, everybody good so far? Okay, let's move on to tangent then. So do you remember the graph of tangent looks like this? So do you remember the tangent graph? In my graph, I wasn't able to draw it, but what is actually in here that we don't know or don't see? Yeah, we have these asymptotes going on here at pi over 2 and negative pi over 2 there. So the tangent function is not 1-to-1, but the tangent with the domain. Now this time I'm not including pi over 2 and negative pi over 2 because what happens at negative pi over 2 and pi over 2? Asymptotes. So, and it's denoted y equals inverse tan of x. So tan and sine have the same domains except that sine includes pi over 2 and negative pi over 2 and tan does not. Okay, let's try to do these. Inverse tan of negative pi root 3. Sorry. So what do we get there? This is the back of your hand, right? So
negative pi over 6. No. What is this figure? What is this figure?
Pi over 3. So negative pi over 3. Inverse tan of positive 1. Pi over 4. Negative pi over 4. Very good. Now we have degrees in there. I don't know why the degrees is in there, but well, that's just this is a 60, which is a pi over 3. So cos of that is a negative what? This would be negative a half, and then inverse of negative 1. Inverse sine of negative a half is
6.
Negative pi over 6. No, but the thing is it was first stated in degrees, so I just put that. Anyways, first we'd have to find sine of 150. Well, that's a 30, right? So that's the pi over 6, right? So that would be 1/2. No, yeah, it's in the second quadrant, but it's still positive with sine, right? So then inverse sine of a half is
Pi over 3. Pi over 3.
No, it's inverse cos of a half.
Inverse cos of a half. Sorry, yeah. Yeah, so it's pi over 3. Yeah. Okay. I'm going to put or 60 degrees, of course. Okay, inverse cos of tan of 0. Tan of 0.
And cos of 0 is 1.
Not cos of 0, it's inverse cos of 0.
She's shaking her head.
It's not cos of 0. That's cos of 0. Inverse cos of 0. Where is the x 0? Pi over 2. Okay, so because that's where cos is 0. At pi over.
Only one where it actually changed, where the inverse actually changed.
No.
Okay, so of course I could go on and on. There's inverse cotangent, and you hardly see these. However, they could be in there, so I would put that on your recipe card as well. Some textbooks use what's called arc sine and arc coast. That's because when you're actually measuring that degree, it's actually the same as the measure of that arc. So watch when you see arc sine in there, it's the same thing. So don't ask me that question later because I've now informed you that you need to know that arc sine is inverse sine, arc coast is inverse coast, yada yada. Okay, so now we're going to do the new stuff, which is derivatives. Okay, so we're going to use implicit differentiation to actually figure out what the derivative of inverse sine is. Okay? So, if y equals inverse sine, then that means I can switch these around and make it into the regular sign, sine of y equals x. Does everybody see that? If y equals inverse sine of x, if I switch them around, now it's not the inverse anymore, it's now the normal sign, right? Okay, and that was by definition of what I showed before. So now we're going to ddx both sides. So what's the derivative of sine of y? Cos of y times y prime. What's the derivative of x? 1. So then what? This is an easy solve. What is dy dx equal to then? Stop it. Try it again. I'm solving for this y prime here. Yes, 1 over cos of y. Okay, so now we're going to recall that sine squared y plus cos squared y equals 1. So we're going to solve for cos y. Can you solve for cos y? Move this over. So what? 1 minus sine squared of y is equal to cos squared of y. Does everybody agree? I moved it over. So then we're going to square root both sides. Yes? So I'm going to get plus or minus the square root of 1 minus sine squared of y is equal to cos of y. Because when I square root, I get 2 answers that can go back in, right? However, because inverse sine is only in this quadrant and this quadrant, can I actually reduce it? Well, maybe not at this point. I'm showing it right here in this quadrant and this quadrant. However, anyways, so let's keep going. So we're only going to deal with the positive right now. So I'm gonna negate this because cos y is only in these 2 quadrants. Yes.
Yeah.
Okay. So it can only be the positive part. So moving on. We're going to now substitute cos y with this cos y. So that means dy dx equals 1 over the square root of 1 minus sine squared y. And back up here, well, this is what I'm trying to prove here. If I have sine y equal to x, what would sine squared y equal to? X squared. So that means that this is equal to 1 over the square root of 1 minus x squared. So I just proved to you that the derivative of inverse sine x is 1 over the square root of 1 minus x squared.
That's not a real question. That's just proven.
I just proved it, yeah. So now you have to memorize the other derivatives. So the derivative cosine, very similar, except that, what's the only difference here? this negative sign.
We don't have a negative.
Okay, make sure you put that in then. The derivative inverse tan, it goes in front of the fraction. Yeah, I don't know why it didn't show up, so make sure you put that in. The derivative of inverse tan is 1 over 1 plus x squared. And then these ones aren't as actual, they're not as used, but I would still have in my back pocket just in case they ever ask you. I'm personally going to concentrate on these three, but for the AP exam, they could ask you any of them, right? So, but I would say these are the most common sine and tan and cos. Okay, and that's why I'm only kind of concentrating on the chain rule is with the inverse sine and inverse cos. Now let's try this. So does everybody see that this is a product rule?
Cal screwed up. No.
Wait, what were the bottom ones on the page?
It's just using the chain rule.
We literally don't have these. These are all good.
They're all different.
Hold on. Okay, so does everybody see this is a chain rule? So this will be your u in the inverse ones at the bottom there, right? Okay, and if you want, you can list it as u and then do it that way. It's up to you how you want to do it. I don't really care. But you could say let u equal blah blah blah, but I think you're past that point that you know how to do the chain rule. So y equals, so the derivative of inverse sine is 1 over the square root of 1 minus x squared. Okay, so but this, because this is a chain rule, it's going to be 1 over the square root of 1 minus u squared times u prime. So my u is the 3x plus 4. So it's going to be 1 over the square root of 1 minus 3x plus 4, the whole thing squared, times the derivative of that, which would be 3.
Nice. Now we simplify.
Now you can simplify. Really, all you do is probably put the 3 on top, right?
That's all we have to do.
You could do that, I guess, but so this would be a FOIL. So 9x squared plus 24x plus 16. So this is going to be 9x squared plus 24x plus 7. Oh, this is a minus. Shoot. This is why we don't simplify.
Don't simplify.
Yeah, this is why we don't simplify. So then we get negative 9x squared minus 24x minus 15. There you go. Yes, y prime. Sorry. Okay. Let's try the next one. The next one is now a product, right? So y prime equals the derivative of the first would be 1. Should I write the 1?
Yeah.
Okay. Then leave the second one alone, plus leave the first one alone, which is x. Now what's the derivative of inverse tan? 1 over 1 plus x squared. Yes? There's no root. There's no root. Okay, so then we could simplify this to be inverse tan x plus x over 1 plus x squared. Yes?
Wait, when it, oh, okay, never mind. He said 1 over. I don't know why.
Okay, the next one is, yes, a chain rule. So this is like the blob thing, right? This is inside. So actually we have a chain rule in a chain rule, right? Yeah. So the derivative of inverse sine is 1 over the square root of 1 minus whatever that is. So that's going to be tan squared 3x. Yes? You have to square it as part of the thing, right? And then now we need to times it by the derivative of the inner. The derivative inner is another chain rule because we have, it's not tan of x, it's tan of 3x, right? So the derivative of tan of 3x, remember the whole, is secant squared 3x, and then we got to times the derivative of the 3x, which is a 3. So I'm going to put the 3 in front just to put that, just to, you don't, yeah. So then I get 3 secant squared x, sorry, 3x over square root of 1 minus tan squared 3x. No. No. Okay. The next one. Do you see the next one is another chain rule?
Don't play this like
So I'll give you a second to try the next one.
1 over minus negative 1 over x, or 1 plus negative 1 over x plus x squared.
This is why you have to bring your stuff.
Negative 1.
Isn't it 1 plus 3x squared? That's not a change. That's 1.
So then I would just kind of clean it up. Negative 1 plus 3x squared over the square root of 1 minus, I'm not going to square that, x plus x cubed, the whole thing squared. There you go.
Oh, I got it.
Right on. Okay. Another particle motion one. You'll see particle motion ones coming up a lot. So everybody knows the basics of particle motion. So the derivative of the displacement is velocity. Velocity is acceleration. So it says a particle moves along x-axis so that the position at any time t is greater than or equal to 0 is x of t is equal to the inverse tan of the square root of t. What is the velocity? So velocity was what again? The derivative. So the first thing we need to do is find the derivative. So v of t is going to be the derivative of this. So I'll give you a second to do that. I would probably rewrite this as t to the power a half. So when you do the chain rule, it's a little bit more obvious, right? Okay.
What over 16? What do I feel like?
So that is, this is a little goofy. To simplify this, it's a little bit more goofy. I'm just going to simplify it one step at a time. Does everybody see the square of the square root is just 1 plus t then? And then this would be times 1 over 2 root t. So what would you, if you had the final thing here, it would be 1 over 2 root t bracket 1 plus t. But it didn't actually ask you to simplify that, so you didn't really necessarily have to. But what you're trying to find is v of 16 here, right? So that's going to be 1 over 2 root 16 times 1 plus 16. So this is 1 over 8 times 17, which is 1 over 56. So 136, 1 over 136, and then what's my units? It doesn't really say, does it?
Units per second.
So units per second. Well, unit, yeah, it doesn't even, yeah, yeah. It usually does say, yeah, per time, yeah. Maybe I should actually be a little bit, units per units per time. I need to fix up that question so it has the units in there. Sorry. So anyways, there's your assignment. They are different if you're looking at the solutions in the orange, just so you know.